Okay, this is the Delta program, and I'm just going to try to show you the timers and counters in Delta program. We've already actually seen the timers. You'll notice with this program, input X0 will start in memory coil M0. So this isn't a physical output like what you saw on the PLC demonstration. This is just kind of in the memory. But X0 will start the memory, and the memory will start the timer. This is a 1 second timer. As you can see, the function block TMR means timer. T0 designates the number of the timer, and 10 represents 10 tenths of a second. So this timer is every 1 second. Now, what does this timer do? Well, this timer T0, every 1 second, this contact closes and it resets the timer. So that's one thing that it does. But then the other thing that it does is every time this timer is in mid-cycle and it hits 5, it gives a count. So basically every cycle of this timer will give a count up to 20. And CNT means counter in Delta. And C0 designates the number of the counter. This is counter 0. 20 down there designates the preset count. And so then at 20, C0, the contact will close and it'll reset the memory, the M0, the memory contact originally that was set, but it'll also set off timer T1. So T1 is the second timer, and it's a 2 second timer. 20 tenths of a second is 2 seconds. And so every 2 seconds, this T1 contact will close and it'll reset. But also midway through that 20 tenths of a second, which is 2 seconds, midway through every 1 second, counter C1 will register a count. And this C1, just like C0, the previous counter, is a 20 count. Once 20 count is hit, the program is complete. So there will be an output of Y0, whatever that would be. And then it'll reset the whole darn thing there. It'll reset C0. So let's take a look at this one in function. And we will I'll force close this input. I'll force it on and force it off. So I forced it on. As you can see, the green starts. That shows that it's forced. I'll force it off. That simulates the momentary contact. As you can see, my timer's going. And my counter is now at 11, 12, 13, 14, 15. So there's my counter. It's up to 20 now. And so counter 0, 20 just made contact. It reset M0, which was up there. C0, now we're at timer, the second timer, which is T1. And it's cycling. And now our counter is up to 6, 7, 8, 9. And hopefully you can zoom in and see that. We're up to 10. And once we hit 20, we will hit our program complete here. Let's see here. We're at 15, 16, 17, 18, 19 count, 20 count. And as you see, we hit 20, and then our C1, once we hit our counter for C1, once we hit our limit, the contact closed and the output to show that the program is complete. And of course that C0 had been green and it just went white, which means it is reset and we're ready to begin the process over. So now I'm going to load the Allen Bradley and we'll see what counters look like in Allen Bradley. Okay, now what we have in front of us now is the Allen Bradley software. And right here is a counter. It says CTU1, which means CTU is counter, U is up. And so CTU, counter up 1. So that's an up counter 1. What you will notice also is there are all these falses and zeros. And these are just because I haven't started the program yet. But this is the counter value. So you will see that value change as the counters change. This PV is the preset value. The preset value of this counter is 7. This is the traffic lights program that I had shown you before. It basically has 7 stages. And so basically what I've used is a timer to cycle, and every time it cycles, it sends an impulse through 7 stages, and you'll see the counter value change. But this is what a counter looks like in the Allen Bradley. One thing that you'll notice in this program is I have used comparators. I have a equal to 0 comparator here. Let's see if we can find some more comparators that are a little bit different. This comparator is a less than 2. This comparator is a greater than 3. So, and this just compares the counter value. So we have counter values, and every time it gets in a different stage, the comparators will compare it, and they'll send an output as to what the light should be doing, whether there should be a green light or a green arrow or a yellow light or a red light. And unfortunately, I don't have a way to really show this because I don't have this PLC, but luckily we can at least see the counters, what they look like in the program, so that if you're ever confronted with an Allen Bradley PLC and someone prints off a program, you'll know what a counter looks like. You'll know which window to look for the value, and we're going to show the counter in action here, so you'll kind of see a little bit about how it works in the program. Okay, so I'm going to start the simulator. So I started the simulator, and as you can see, it's going to change different lights. You can tell number output 4 just turned on. So 4, 5, 6, 7 are on. Now 7 and 10 are on, and 1 are on. These are just different lights. These are outputs for different lights. But let's look at the program and see how the counter is reacting. Okay, so right here our counter value is on 5, and our total count is 7. Now it's on station 6. Our total count is 7. Once it hits 7, then the next one will be, 0. See, it's back to 0. So this is kind of our counter value. It's 1. So, you can see the counter, the up counter, it has a 7 value, and this could be counting anything right here. We're just counting stations, but we could be counting things along the assembly line or whatever. And if someone were to look at this on the software, whether remotely or just plugged directly into the PLC, they'd see we're at station 4, we're at counter value 4, we're at counter value 5, we're at counter value, we'll be at 6 here, we're at 6. Then we'll go to counter value 7 and then 0. It kind of skipped. So anyways, as you can see, that's kind of the counter, what it looks like in the Allen Bradley. I've shown kind of how timers can be linked up to counters to kind of go through a sequential process. We have seen comparators for counters using the function of equal to, greater than, or less than to turn on and off outputs depending on where the counter is at with its count. So that's the Allen Bradley. I think our next video we're going to do data registers. So, just tune in to the next one, and we'll see you then. Thank you. Bye.